So we will start in 5 minutes. welcome. The microphone is on. I hope that you can hear. It should be. Hello, hello. Hello, hello. So, hello, yes. Well, the signals are coming here. It's not. Hmm. Oh yeah, yeah, it's on. Yeah, it's just the volume is not high enough. But well, let's start by making it interactive. So, if there are people online, can you hear us? If you can hear us, please reply on Discord. Well, first of all, is anybody attending online?
Maybe he's saying that he does not hear anything.
Mirao, are you here with us?
Yes, but the sound is very low.
Okay. How about now? Is it better? Hello, Mirao. So it should work out. So we are going to do a lot of window switching because that's how we work with hybrid presentations, online and presence. And unfortunately for people who are online, people who are here will have one more advantage. They will see us. People who are online, well, apparently they can hear us, though, so that's good for now. So welcome to this workshop entitled Creating Spontaneous and Mobile Immersive Spaces Using FLOSS. So by FLOSS, we don't mean dental floss, but free, libre, open source software. I'll make it easier for you to read that slide. So we are here at the Graphics Interface 2022 conference, and it's, I think, the first year that this conference is hosting workshops. So Mirao is telling us that the sound is still a bit low, so I'm going to increase a bit, and hoping for the best. Actually, we are 3 presenters, and Mirao is one of them, and unfortunately he couldn't come today because of a well-known illness that is going around the world. So I am Christian Frisson. This is Emmanuel Durand. We are both working at the Society of Arts and Technology here in Montreal and at the MetaLab. So Emmanuel is one of the co-directors of the MetaLab, which is the research and development department. And I am a researcher and developer, so is Mirao. And we are combining our different skills in computer graphics, audio and haptic feedback, and computer-human interaction, or human-computer interaction. So, can you recognize where this picture has been shot? In which city? So, Montreal, right? All right. So, have you visited that place? Yes? So, I'm going to give you another viewpoint that is here. So, have some of you played video games such as like one quite old Myst? It's a point-and-click game from the 90s. This picture reminds me a bit of that game. It looks like a bit unreal. And is there something else you can see in this picture? Like near the cursor, for instance. It's quite small. So this is the biosphere. So both of these physical artifacts, they've been created particularly and on purpose for the 1967 World Exhibition in Montreal. And so the biosphere is now a museum for the environment. And Habitat 67 is housing for people who have enough money to afford it. So this is another viewpoint of the Habitat 67. So may look like a kind of usual neighborhood, kind of not. That you may see that the lawn is quite well mowed. But if we look at another viewpoint like this one, looks a bit even more futuristic. But so now we're in 2022. How will it look in 2067, 1 century after? So what we are proposing here is we are gonna prepare a setting to ideate on how it may look. And we think it may look like this with like many more of those building cells. The interstate rail system that is has been finally built 100 years after between the cities of Montreal, Ottawa, and Toronto. So we are gonna do a small setting that uses computer graphics, so projection mapping, not sound spatialization today, and human-computer interaction using cameras. So how we're going to go for this workshop is, so I just introduced the workshop, and we are going to present 3 tools. And for each tool, we're going to do a short presentation of their scope, and we are going to do a hands-on demonstration, and we are going to construct a demo with these tools that are open source so that you can see what you may want to do with them if you're interested in that matter. And at the end, we are going to open the discussion for potential use cases that you may be interested in. So you could hear some sound notification. Okay, so I'm going to take the microphone. So Samuel is suggesting that in OBS we may add some gain filters in the mic aux setup by clicking on the gear and maybe add like 15 decibels in the audio, or I can try to use my sound card to make that work, and I'm going to adjust the levels with some visual feedback here. So is it clipping now? Yeah. So we'll try to follow Mirao's advice, who is our sound specialist, is to speak directly to the microphone. All right. Thank you, online people. So let's start with open source tools. We're going to start with Splash, one open source tool for projection mapping. Then we are going to quickly overview Sati, which is a tool for sound spatialization, and LivePose, a tool for camera-based interaction. So starting with Splash, I will give the microphone to Manu.
Thank you, Christian. Hello, everybody. I did not have the occasion yet. Before I start saying anything about that, I wonder who played with projection mapping before, or this kind of device to implement immersive spaces or this kind of stuff. Okay, nobody. So I won't say anything that you already knew, which is a good thing, I think. All right. So projection mapping, there is a definition which is, I think, which fits most of its uses, and which is on projectionmapping.org. So I use it every time I want to present that. So it uses everyday video projectors, but instead of projecting on flat screens, light is mapped onto any surface. So turning common objects of any 3D shape into interactive displays. So it also works with flat screens anyway, and sometimes it's a combination of multiple flat screens. And one characteristics of the 3D object that is not mentioned in there is that obviously the 3D objects must not be too specular or it won't work, obviously. So projecting onto arbitrary geometries, it can be like these small cubes which sits on a desktop, or it can be more immersive spaces like this inverse dome, which has been created here at in Montreal at the SAT, and it's called a panoscope. And the idea is to have a single user immersive space to, well, have immersive experiences basically. Also, what's possible is to project onto moving object, and I just, opla. And so I'll go forward a bit faster than this. And so the idea with this is to track 3D objects and adapt the projection mapping in real time so that it matches the position of the 3D objects. And so in this case, we used off-the-shelf hardware, so it's Vive trackers. And in this case, we had like 3 video projectors, and yeah, so we tried to do something a bit interactive, and so this was mostly done with our own internal software, except for the part that uses the accesses the HTC Vive. So what are the problems that projection mapping tries to resolve? Basically, when you try to do projection mapping, you try to fit a virtual 3D object onto its real counterpart. So basically, you first have to have this virtual 3D representation of the real object. So in this case, it's really easy. It's a cube, which is more or less precise, but precise enough. And what's used to calibrate the projection is that we match some vertices from the virtual 3D model onto the real 3D model. So in this case, we managed to fit like 7. Yeah, sorry, I'm looking at there because I have exactly the same thing. So we have like 7 points. It can be more. Usually it's not less, because with less points it's not possible to calibrate all the intrinsic and extrinsic parameters of the projector. Another problem that has to be solved is whenever you want to use multiple projectors. And in this case, usually it's not possible to have precisely each projector projecting onto its own surface unless you are using flat surfaces, and in this case you might be able to do it. So you will have overlap. And so you have to take for account the fact that multiple projectors can display onto the same portion of the 3D surface. In this case, we have like at most, I think it's 2 projectors at the same place. It's easy to see on the image, but it can be many more. Like in the full dome that we have at the SAT, we have sections where we have 4 projectors projecting onto the same part. And yeah, so the idea is that this is a workshop, so obviously if you have any questions along the way, don't hesitate. And what we want to do during this workshop, so as Christian said, is to calibrate a small immersive space for Playmobil, which is right here on the desk. And so we will go through first Splash, and I will show you how it works and what it does. And hopefully everything will work as previously tested, because demo effect and everything. So let's go. I'll try to keep this not too far from me.
And then once Manu has set up the first part of this installation, we are going to open a first round of questions for this part. And first, people who are here in presence, and then online. So we can interact. So I'm going to put it closer to you.
Yep. And if you can switch to Zoom.
Yep.
So for this, obviously, I will use our own in-house software, which is called Splash, which does projection mapping, which is used inside our full dome, and so it handles mostly daily 8 projectors, and in this case we have only 2.
Share the screen.
Oh yeah.
Pardon the interruption.
Yes, and so I pre-calibrated some stuff before because I wanted to make sure that everything works. So it will seem a bit easier than it is in reality. So this is what Splash looks like. So hop. So I won't go through all the interface. So we will share with you all the links to Splash documentation and the other software documentation, and also to this very presentation so that you can go through it if you want later on. But basically, what we have here, well, it's the main screen. So I'm sorry I can't make things bigger because it's not implemented, but it's open source. So yeah, one thing that can be of importance to some people is that we develop all our software on the free licenses. So Splash is GPL, and I think the other two are GPL. Yeah, obviously we are eager for contributions, be it on the documentation or bug reports or this kind of contribution. So as I said, I pre-calibrated most of the setup, and what you can see here, very small. Sorry for that. Is a node-based configuration. So basically, what we have is that we have 2 inputs, like an image, which is pattern just to be used for to help us with the calibration, and a 3D model, which looks like this, and which happens to look a lot like this physical object, which is a good thing in our case. And so this is the image, this is the mesh, and all these are they are connected to 2 projectors. This one is the user interface, which has its own node, so it does not count. So we have 2 projectors, and then in the end the window. So we have a single window which spans across the 2 projectors. So I won't go into too much detail, but Splash is built to be very flexible, which is a good and a bad thing at the same time, because it's good because it allows for handling many different setups. So you can project onto a lot of projectors with multiple GPUs and this kind of stuff. On the other hand, it does not automate that many things, and so it's a bit hard to, well, when you start with it, to configure as you want to. So we have quite a lot of tutorials nowadays, so this helps, but obviously it takes a bit of time to handle. But we know of users who were able to set up quite complex installations without asking for any help at all, yeah, so which I think it's a good sign that it's usable, at least. So there is just one window which spans across the 2 projectors because it gives better performances, basically. So it's not obvious in this kind of simple setup, but when you have 8 projectors and that you want to display on all of them, if we had 8 windows, it would mean 8 context switching for the 3D rendering, and this eats performance alive, basically. So that's it. So we have this this setup, and then whenever you run Splash and you have configured the node-based configuration, it does not at all look like that. It looks like this. So, so you have, I'll just remove everything just to make sure that it's in the default configuration. And so I can select both projectors basically. So if you look, it's highlighted with an orange aura. And so that I know which projectors I'm working with right now. And the idea, as I said earlier, is to, how to say it, select the vertices from the 3D object and tell the software where it should be projected. So what I do is that I can select a vertex like this one, and it should be projected right here. So with some shift clicking, which is explained in the documentation once again, so I won't go in too much details around that. I place a cross, which is displayed onto the surface, and I just put it where it should be projected. And I do this for all, well, not all the points, luckily, because otherwise it would take very too much time, but for at least 6 points. If you set less than 6 points, Splash will refuse to do anything. So. So I'll just do one from start to finish, just to prove you that it works. Yep. It does not. It does not know the depth. The thing is that what I'm trying to do when I do this process is that by having at least 6 or 7 points, with 7 we have a better chance finding the right parameters. With 6, usually it works, but sometimes it does not. What I'm trying to do is that I'm asking the software to find the intrinsics and extrinsic parameters of the projector. So it's focal position in the referential of the 3D model. So I'm trying to mimic what the projector is in real life inside Splash. And once this is done, the Splash will film the virtual object, and it will be projected onto the real one, and they will be aligned, basically. So I will continue with this just to... Yep.
How do you know where it should be projected, like those points that you are marking in the
Oh. Okay, that's a good question. What I could show you is that... Okay.
Let's repeat the question.
Yeah, so the question was, sorry, yeah, I should repeat the question. How do I know which point should be projected where, basically? So I created the 3D model to match the 3D object. And so I know that this vertex, which is highlighted in red, should be projected onto this point. It's it's where it should be. And the thing is that I placed the projectors so that both of them, they project onto the whole surface. And so, yeah, with this, I'm capable of selecting all of the points. And
It's a very approximate guess of where it should be.
Well, in this case, it's not pixel perfect or better than that, but it's precise enough because I measured the 3D model and the physical object, and I reproduced it in 3D. And so I know that this vertex should be there.
But how do you know where to project this maybe it'll become clear.
Maybe it's because you don't see it from where you are.
Come closer.
Yeah, that I think that's the thing. Yeah, sorry.
That's fine.
Okay. Because okay, just so you see it from the other side, you will see better there. You see, whenever I select like this point, it should be projected exactly here. And so I have another marker which I will try to make visible. Yes, this one. This cross is the target. And so this point should be projected. Well, here I ask it to project here, so it won't work. But yeah, that's how it works. Yeah. So I should have brought a bigger room. The idea at the beginning was to project inside the room, but we thought that it was a bit too risky to not know the room beforehand. So I'll continue with that. So yeah, you saw I changed the 3D model to have a simpler one so that I can't select the wrong vertex, but it's the same scale. The other one is just a subdivided version of this one. And I will explain later why it's useful. So I will place all of them. I'll try to do this quickly. Up. Okay, and this one. And hop, here it is. So it works. So yeah, it's if you check so we have one face which is there, the other one, and yeah. So this works. Yes.
I just interrupted, so let's go with it. There is another question online.
Yes.
From Jerry, if you don't mind switching to Discord.
So what hardware have you used for 8 projectors setup? CPU, GPU, OS, projectors. So OS, that's an easy question. It's always Linux. So we develop on Linux, we test on Linux. Some of our software might work on other operating systems, but we don't have time to test for them because we already manage too many software and we can't manage too many software on too many operating systems. Regarding CPU and GPU, CPU-wise, well, Splash is not that hungry. In fact, we started developing it in 2014, and I think it would still work in 2014. CPU-wise. On the GPU side, it's a bit hungrier than that, but you see, it works on this laptop, and I think with this laptop, I might be able to run the 8 projector Full HD setup, given the right splitters and everything. But usually, what we do is that in the context of big projection screens, you have to make sure that all the projectors are synchronized. Otherwise, you will see it will not be vertical sync issues, but it will be the multiple outputs which are not synchronized. And so usually we use NVIDIA Quadro cards or similar from AMD, and with the synchronization card. And so that we know that all the outputs are synchronized. And well, it's not always perfect because sometimes the projectors, they have their own life and their own, they do what they want sometimes, but usually it helps. And this heavily depends on the display size, because on this kind of setup, you won't see anything because it's too small, and you won't see that the projectors are not synchronized. In the full dome of the SAT, which is 18 meters wide, it's really easy to get a displacement of like, I don't know, 20 centimeters between two frames. And so it, you see it, you can't not see it. So, yeah. And regarding the projectors, well, it really depends. This is a question of scenography, I guess. It really depends on what you want to do. In this case, these are off-the-shelf LED projectors. And in our full dome, well, we have Christie's projectors, big 20K lumen projectors, which are meant for this kind of use. Yep. Yes, and the laptop, this has a 1660 NVIDIA GPU, which should be easy to obtain, but these days with GPUs, you never know. But yeah. So, yep, any other question? No, okay. So just to show you, so we calibrated one projector, and as you can see, there is a view where we can see the whole setup, and it displays, well, the projectors, which is replaced by a camera, because in Splash, it's a virtual camera, and it's orientated more or less like this projector. So it's on the side, and yeah. So this should prove that it does what it does. So I will reload the whole setup, just not to go through the configuration again with the other projector. So here is the same stuff, but with both projectors calibrated. So this one, you see all the points and everything, and the other one with all of the points again. And then if I display a texture onto that, so this is an equirectangular. No, it's still the input texture from earlier, and so it's mapped onto this 3D model. However, it's mapped. It does not matter. So I can say two things about that. First thing is that I showed you earlier that I have two 3D models for the surface. In fact, well, in this case, I have two. And so this one and one with a lower mesh resolution. And the thing is that if I load the lower mesh resolution one, hop. Okay, well, in this case, it worked. Okay, that's a bad example. The thing is that the texture coordinates, they are not the same. You see, in this case, it's just that each plane is showing a part of the texture. For the other one, the higher resolution 3D model, the texture coordinates are computed to display an equirectangular immersive image. And the thing is that if you don't have enough resolution in your 3D mesh, you will see jagged edges. It won't be, you will see artifacts. So you have to use a subdivided 3D model for this kind of projection. Okay, so one last thing, I think, and after that I will have finished with Splash. Is that you see the overlapping of the two projectors right here? So you see that this is more luminous than the rest of the space. So this is one thing that really makes Splash useful, beside the automatic calibration. It's that it computes the blending automatically. So to do that, it has to know where the projectors are located and what the 3D surface is. So we already saw that. So you see the other projector is also calibrated correctly. And from this, it can compute the amount of light that each projector should project. So it can compensate for that. And so, yep, activated that activity.
I see some like more than this toward the predictor. Can you compensate for that?
Yes. Yes, that's possible. I did not activate it there. And it should be somewhere in the oh, it might be. Yep, this. It's not perfect. Okay, it's not perfect, but did. Oh yes, it's better. Yeah. So I did not. I moved maybe a bit the projector, so the blending is not perfect. But yeah. So yeah, in this case, I activated the depth-aware blending. The thing with that, it's not activated automatically, because if you have projectors which are at a very different distance from the projection screen or the surface, it will map onto the lowest projection, the lowest luminance of the surface, and so you might get everything that is dark because of this. So, yep. So I guess that's it. Yeah, you need a better projector, or you need to rethink how your projectors are positioned. And in a lot of cases, you don't need this. So to come back to the example of our full dome, all projectors, from where they project mostly onto planes. It's not the case, because obviously it's a dome, but from the distance of the projectors, it does not matter that much that that the surface is curved. Well, in practice, obviously in theory it does, but in practice you don't see the issue with this. So yeah, that's it. And on top of that, whenever the result is not good enough and your 3D model was not precise enough for your calibration to work, we can do some warping. So just you move by hand the output, and yeah, you can make things better with that. Usually, yeah, I don't like it, because the thing with that is that you introduce deformation. You never know that it's that the result is indeed good, and also it will never work if you try to project onto a mobile object, because you modify the warp for this precise setup. If you add a 3D object, even if you know its 3D location, the warp won't be the same. And so, yeah, usually it's really better when you don't use this, but it's there because sometimes you can do otherwise. So that's it for this part. Any question? Yes.
So what happens if you add a cube right now? You have all the recalibration from scratch, or you will have it?
Okay. So the question is, what happens if we add another object, basically, inside the scene right now? Well, Splash already knows the position of the 3D of the projectors, so you don't have to recalibrate that. It won't change. What you have to do is have a 3D model of the new object that you add inside the scene and know its position. So as long as you know its position precisely enough, which might depend on the setup, and the resolution of your projectors and a lot of stuff. But if you know its position and you have a 3D model, it should be okay. And this is exactly what is done in the projection onto mobile objects that I showed earlier. It's that the projectors, they have been calibrated with immobile object, fixed object, and then the mobile cubes, they are tracked by the HTC Vive tracker, and so I know in the 3D space where they are located, but I don't have to recalibrate the projectors.
The colorful cubes then.
Yes, exactly. Okay. Any other question? No? Okay. So let's go forward with I will keep this like this with Sati. So Michał, I hope I won't say too many, won't do too many mistakes. You can judge me. I have to.
You can project the slides from your computer so that we can hear display.
Okay.
Let's try to.
It's on the.
Okay. So I'll pass you back the mic.
Okay. So we do a continuous integration with our software, and so which is why these slides have been compiled on our software and are available anywhere. So yeah, so I went through the video part, well, projection mapping at least, and so we have a similar tool for audio. So which does audio spatialization. So it's called SATI, which is an anagram for Spatial Audio Toolkit for Immersive Environments, and obviously it's named after the compositor, Eric Satie, and yep, yeah, and we have another software which is called Varese for another compositor, which also does audio. So yeah, so this software is meant to do audio spatialization. So there are other tools which does that. Obviously, in 3D gaming, it has become very common. The thing with SATI is, well, it's synchronized with 3D engines, which is usually what's happening with game engine, well, with audio rendering system, which are linked to game engines, but it's not always the case for other spatialization engine which are meant for artists. So this one is can be synchronized with 3D engines. It's capable of handling a lot of audio speakers, and yep, that's me who says I've made a mistake, right? Ah, okay. So yeah, it's capable of handling a lot of audio speakers. So to stay with our full dome, we have 31 channels which are handled by, which can be handled by SATI, and SATI is also capable of doing multiple simultaneous audio rendering. What this means is that, for example, we have a full dome of audio speakers. So our speakers, they are placed onto a dome, which is behind, obviously, the projection surface, but it's still there, even if you don't see it. SATI is also capable of rendering at the same time the audio for like binaural rendering. A single user could have their own binaural rendering at the same time that there is a rendering for the dome of speaker. And so we can, like this, multiple the kind of audio rendering types. And what this allows for example, so in the context of, well, usually when you have immersive audio, well, audio immersive space, immersive audio spaces, I don't know, whichever order. All the sound sources, they have to be located outside of the setup. So in the case of a dome, you can't simulate an audio source which is inside the dome. Well, you could for a single person, but not for everybody. And so what this means is that, for example, in our dome, all the audio sources, they have to be located like 10 meters from the public at least. And with the possibility to do multiple audio renderings, we can add some other speakers inside the dome and use them to do to add some new well, audio sources, and so we can do it so that audio sources, they come from far, which is rendered by the dome, then they go through the dome, and then they are rendered by the singular speakers that are placed inside it, and then they go outside on the other side. So yeah, SATI is capable of that, and as far as I know, it's the only one which can do that. And also it's capable of handling many audio sources, so I don't know what the exact count nowadays, how many it can handle, but I know that we already managed to make it render, like, I look at Mihao because, yeah, this, like 500 or 600 audio sources at the same time, which is enough for a lot of uses. So SATI, why? So this illustrates, I think. Oh, there is no sound. Oh, that's because I do the. Okay. Yep. Okay, so there is no sound. Sorry for that. So I can simulate it. So, well, what this illustrates, it's an add-on for SATI inside Blender. So we are capable of attaching an audio source to an object in Blender, and yeah, play with the audio rendering this way. Yeah. Anyway, I'll go back. I'll go to the next slide. Hop. Thanks. Oh, this is very small. Okay.
Question.
Yes.
I guess you mentioned it, but why was that the speakers had to be outside?
It's not the speakers. It's the virtual audio sources, because it's the same with a stereo setup. Whenever you have a stereo setup and you try to play a sound, it will always appear from beyond the speakers. It can appear to be right in front of you, but it will work only for one people or at one given position. But for anybody who is on the side, it will be off, it will be misplaced, and yeah. So the best way to consider is to consider that all the sources are beyond the audio reproduction surface, something like that. Yeah, and yes, yeah. So in the case of a dome, so it has to be beyond the surface of the dome. But it's exactly the same phenomena that happens for video. In the case of video immersive space, you can't represent correctly for everybody at once an object that is inside the immersive space. It has to be beyond, because if it's inside, it will be completely deformed, and the scale will be off, and everything. And well, in fact, the closer the object is to the surface, the more wrong it will appear. But anyway, you have to take this into account, and yeah, so it's exactly the same phenomena. And once again, this can be fixed for a single person, which is in caves, for example, people are tracked, but it's always one people who is tracked, and so it works for him because the rendering is adapted to where he is, and so this can be also something which works in a dome, but it will always work for one people, and in our full dome, we can have like 100 people at the same time. And this we did not mention this, but at the SAT, what we try to concentrate on, I don't know if it's that the right way to do to say it, is that we try to work toward developing tools to help with deploying collective immersive spaces. So we don't do virtual reality headsets, for example. We don't work with this kind of tool. We work with tools which help like deploy immersive spaces in this kind of space. So this explains some of the stuff. Sorry, Michał, I don't know as much as you, so I won't be able to give examples, but you can mention some in Discord. Okay. So with Sati, you can add live inputs. So it's mainly built around having live inputs and do some audio synthesis, and you can add effects onto the objects. And to communicate with Sati, it's mostly with OSC, Open Sound Control, which is very common for audio people. And we already have used it with success with Godot, a free game engine, Unity, Blender, and some other more audio-related software like Max for Live, Pure Data, and a few other ones, I think. But I guess, okay. And so an example of Sati in action. If this works. Case, you can see each ball is a sound source. So we have, I don't know, 100 of them? So obviously all of this is more impressive in an immersive space. And that's it for Sati. Michał, do you want to add anything that I have forgotten? Okay, so it's good. So,
I had a question.
yes.
So a lot of the concepts that you're discussing over here with, for example, the sound objects type, or sound sources tied to sound individual objects, or being able to calibrate for an arbitrary number of speakers. It sounds, it reminds me a lot of how technology like Dolby Atmos works. So could you expand a little bit on what makes Sati stand out apart from industry standard tools like that?
Yes, that's a question from Michał. So, Michał, the question is what was described for Sati looks a lot like what, for example, Dolby Atmos does. And so the question is, how does Sati stands out and is special in this regard? I would say the first thing would be it's free.
Very true.
It's free and not proprietary. Yes. So I think the multi-system rendering is very specific to Sati too. But I can, I'm not exactly sure about this, but this is not something that happens usually that you have multiple rendering audio systems at the same time. It's very specific. So yeah, and that's exactly what Miho just said. And so I think this might be the most specific, specificity of SATI, besides being free open source and this kind of stuff. So yeah. Any other question? No? Okay. So your turn. Yep.
There was one more question
Oh.
from Jerry.
Oh, so from Jared, do the demo videos do spatial audio in headphones? So, Michał, are they rendered in binaural or not? Okay, it could. Anyway, SATI can do binaural, so I don't know if in these videos it was rendered in binaural. Yes. Okay. But yeah, the thing with binaural is that compared to stereo, is that it works for some people and it does not for others. I don't know if you tried some binaural demos, any kind of demo, because there has been a lot throughout the years. But yeah, as it uses like standard mean model for the ear, anybody who has an ear which is outside of the mean, they won't hear the spatial audio as well. So sometimes it's just better to use stereo so that it works the same for everybody. But I don't know for this specific video. Okay. Yep. Yeah. Ideally, everybody could have their personalized HRTF, which is
Related transfer function.
yes. So yeah, but not everybody can go and measure their own HRTF and everything. Yep.
And it's possible to do with SATI. Oh, there was one last comment from Mirao coming. Suspense. So there are some. So SC stands for Super Collider. It's and like Mirao said earlier in the chat, it's what powers SATI. It's a sound synthesis toolkit and engine. So there are some libraries for high order ambisonics HOA that has some preset for popular headphones for this purpose. All right. So let's switch to the third tool, whose name is Live Pose, and it is for camera-based interaction. And I'll give you a hint. It's going to be this camera here. You all belong to us. You would have seen it probably somewhere here, right? Yeah. But maybe we can record with OBS. Anyway, so Live Pose is a tool for real-time pose estimation for video streams. So what is a pose? The pose of a person is it's a combination of body points from the joints that are connected with bones and segments, and so that we can analyze like the posture of people, how they move, and going towards action detection. And this is one example of Live Pose running in the Satosphere, which is SAT's huge dome that is on top of the building. And here we see people moving in that space, being tracked by a camera, and the pose that we extract from the video feed is overlaid on their body. So as you can see, sometimes it works, sometimes it's jittery. It's computer vision and deep learning. And sometimes some of the joints disappear. But roughly, we can see that at least the position is trackable. Okay. They seem to enjoy being there and moving around. All right. So one of the main goal of live pose, well, here it's written accessibility, but it should be availability. The point is to make it easy for artists and also researchers to use the state-of-the-art techniques from pose estimation using deep learning and computer vision. Because, for instance, well, to install everything to run live pose on a computer, if we had to compile everything manually, it would take 1 week, even if you know what you're doing. So here, the main contribution of live pose is that we package everything, and it's almost ready to use. Well, if you have a Linux computer or a small embedded edge device, such as the ones that NVIDIA produces, the Jetson models. So that being said, live pose may be used in cases to solve issues like for people with specific needs for accessibility, actually. By that, we mean some people have motor impairments, and they may only make use of their eyes or face. So we are also working towards applications of live pose for, say, controlling like the animation of avatars in virtual worlds using the face. We'll see an example later. So it's easy to install on this machine, which runs Ubuntu so 2004, 2020 April. We are using long-term support releases because packaging takes time, and we are focusing on making it work out of the box on as few boxes that we can, but at least one. And how, well, besides packaging, how can it be made easier for artists to use it is to use their languages or their protocols that they use for sequencing and authoring their immersive spaces, their installations, their performances. And one protocol is Open Sound Control that Manu mentioned earlier. It's a network-based protocol to exchange control and data between applications. It's the, let's say, industry standard, including ATSAT. And here is an example of Manu, who is here, controlling like the viewpoint in Mozilla hubs that SAT forked and adapted as into satellite. It's a virtual environment that can be used for meetings, online teaching, and performances. So here we have the pose of Manu's face overlaid, detected and overlaid onto his face. So it's quite stable and appears to be effective in controlling the movements into the virtual world. And this uses another protocol, WebSocket, to connect live pose and a web-based application. So again, Mozilla hubs. And so we are bringing the state-of-the-art of pose estimation into the hands or into the boxes of artists. And those are three, here we have a list of three backends, deep learning backends that we have embedded. PoseNet, TRT Pose, TRT stands for Tensor RT. It's using a lot of optimization libraries from NVIDIA. And MMPose, it's a collection of many like bleeding edge techniques that that are being published, even like CVPR 2022, and it's an organization that brings all of these models into one library. And here we are using TRT pose because this is the most, at least it's the fastest and the most stable. So if we run the first one, PoseNet can run on CPUs only, not necessarily with NVIDIA GPUs. And at best, it runs at like 5 frames per second or 10, roughly, with CPU. Okay, but roughly 20, 30 at best. And TRT pose, for instance, we went up to 150 frames per second. Why is it important? Is like if we control, say, music or sound synthesis with pose estimation, if the frame rate is too low, we will hear delays or scales, or because it's not fast enough. And so it runs on small embedded optimized boards. For instance, these produced by NVIDIA, the Jetsons. So that it can run out of the box and really, like, we open the box with that specific board, we hand it off to people and they can use it. And we are currently working towards action detection, because here, well, action detection is a higher level feature than pose detection. And so that artists can compose with gestures and actions such as raising arm, jumping, or some more complex interactions between people even. So now let's add live pose to this installation, and
I will do it. So any questions before that? No? Yep.
Question with the live pose. Can it take, can it estimate poses from multiple sources of video, so that more than one camera?
Okay, so the question is whether a live pose can handle more than one camera, and the answer is yes. We made it run with, in real time, I think 4 cameras at the same time. So yeah, it has its own issues, obviously, between the synchronization of the multiple feeds and this kind of stuff. And some of our work is toward adding 3D pose estimation using multiple cameras. It's already possible in specific cases like this, the one that we will present in a few minutes, using depth cameras, because this is a depth camera. But when you have bigger scale installations, depth cameras they can be used because the depth estimation is not good enough, and so you have to rely on epipolar geometry and this kind of stuff. And so yeah, this is something that we want to add. Maybe it will be added during the summer, because we have been selected for the Google Summer of Code, and we might have somebody who will work on that. And also one characteristic of live pose that is not mentioned is that it's meant to be modular, in the sense that, as Christian said, it can run on NVIDIA Jetsons. So which are single board computers, and so what we want to do, and we are very close to this, is to have a Jetson with its own camera, detect the pose, send the pose estimation for a single camera to a server, which would gather the pose feeds from multiple Jetsons, and so multiple cameras, and do a more complete representation of what happens based on all these pose estimations. And yeah, so this would kind of not remove, but at least improve upon the the need for GPU power, basically, to do the pose estimation, because it really eats a lot of GPU power. So we could have a lot of jetsons, and each one with its own GPU and everything. And also it would help with placing cameras throughout a big space, because currently these cameras, for example, they are USB cameras, and you can obviously use USB extenders, but it does not always work that well. And if you want to connect, like, I don't know, 10 cameras onto a single computer, you will run into issues regarding the number of USB buses that you have on your computer, and you will run into issues. We tried it. It will not work correctly. And so the idea that you connect cameras to separate devices and just use network to transmit the detected poses is, well, to me at least, interesting. But this is not implemented yet. This is in the roadmap. Yep.
Just two small additions. So this is just to show you the rough size of a Jensen device. It's basically like palm-sized, and also we could run 8 cameras at the same time for recording with the Montreal Symphonic Orchestra, I think, on the same computer, but that was a desktop.
On the desktop
But
it was 10. We worked with the 10 USB cameras. For the we still have partnership with the MSO, Montreal Symphonic Orchestra, and where we did some recording with using ambisonic microphones, so spatial audio microphones, and also we recorded their poses with cameras, and we wanted to have all of this synchronized enough, and so we connected all the USB cameras to a single computer, and we were not able to connect all that we have. So we have 16 of these cameras, and we were able to work with 10. So yeah, using the network to be able to connect many more cameras is an interesting solution. It's not always the... Sorry?
My experience with the network connections, like the NDI cameras,
Yeah.
there's a lot of latency.
Yeah.
And it's not consistent. So it'll just like fluctuate, and there'll be typically about
Yeah.
a second delay.
So yeah, indeed. So I don't know your name. Sorry. Sheldon just mentioned that using like NDI to transmit video feeds through the network leads to latency and desynchronization, basically. And yeah, that's one of the issues that will arise with network connection, obviously, the synchronization of multiple cameras. So I'm not.
One interesting solution that we do some experiments with live tracking as well, where you can get cameras that have Genlock,
Yep.
ad hoc Genlock, and so you can actually connect them like without a Genlock generator. You don't need a generator for the Genlock signal. The cameras themselves can do it.
Yeah.
So we're actually working with some of those cameras now. I'll see how well it works.
Yeah. Well, in fact, these cameras, the inter-real sense, you can handmade some genlock. So there is a port which is kind of hidden, and you can do some genlocking with them. But it messes up with the depth estimation. So if you want depth estimation, you can do that. So yeah, we might transmit the video frames using the jetsons, but we also want to try without that. Just transmit the pose estimation. So it won't be the whole video frames, it will be only the poses, so it will eat less bandwidth. And regarding the latency, I don't know. It might help, it might not. I really don't know, because anyway, you still have the latency for the detection itself, and then all the jetsons might not run at the same rate, because some of these detection algorithms, they take more time the more people are visible, and some do not. But yeah, it varies a lot. So we will see. Uh, any other question? Okay. So, yeah.
There was just one more question online by Jerry, is whether or not high-resolution Jiggy cameras were supported as well as USB. And so we are using OpenCV and LibRealSense. So LibRealSense is the library made by Intel for these cameras. So theoretically, LivePose supports all cameras that are supported by those libraries as long as their support is enabled at compilation time. So for instance, we did not activate older cameras such as Kinect because we don't use them anymore, and they're outperformed by these. But yeah, it's again along that scope of focusing on one single box that works. But yeah, so
yep. Merci. Yeah. So yeah, we work a lot with the Intel RealSenses, but LivePose works very well with webcams. We test it a lot with webcams. You don't get depth in this case, but it still works. Okay, so what I will show now is how to use LivePose alongside Splash to make something interactive and allow for the user to be a bit more immersed into the virtual space. So before that, a bit of context, I guess. Are you familiar with the immersive projection and this kind of stuff? No, not that much. Whenever you want to generate content to be displayed into an immersive space, you have to do the rendering so that it can represent the 360 rendering, basically. So if you work with a VR headset, you don't have to do that. What you need is just one rendering for the left eye and one for the right eye, and that's all. And I'm oversimplifying stuff there, so it's not that easy. But basically, that's on the rendering part. That's what you need. If you are inside a cave or a full dome or this kind of space, you have to render for all the sides at the same time. You don't know where the user is looking at. Well, except if there is one single user and you know where he is and everything. But if you have 100 people, you have to render considering that anybody can look into any direction. And so there are multiple projections that exist for that. And for full dome, what's usually used is what's called Dome Master, which is basically a spherical rendering, which looks like, why don't I find something interesting now? It always works well. It can look like this, more or less. So top is what's displayed on top, and then you have left, right, back, and front. I should not rely on the internet to give me interesting stuff. Yeah, that's a bit better. So this one, for example, this one is interesting. So at the center, you see the sky, and then the further you go from the center, and the more it's what's projected onto the bottom of the dome. So if you imagine a dome, so what's up would be the sky, and then you go further from the center, and you get the ground, and then you get to the bottom of the full dome. So this kind of, so it's more or less like a fisheye. It's in fact, I think it's exactly similar to an equisolid fisheye, which is a special kind of fisheye camera. And yeah, the thing is that it's not generic. So you have to do your rendering for like a full dome, which covers 180 degrees, and you won't display anything beneath this. And so you have to do your rendering specifically for one type of full dome. And if you do a 360 degree, it's not really interesting because the outer circle will represent, in fact, one point which is at the bottom. So it's really not effective regarding the density of information that is stored inside the texture. So what can be used also? Well, obviously, cube maps. So cube maps. Everybody knows cube maps. So usually it's not organized like textured cube map. So it's more like a 3x2 matrix, and you have like left, front, right, and then bottom, back, and top, something like that. Or this works quite well. Or you can have also, this one is not a cube map, it's an equirectangular projection, and which is also pretty common. So this is more or less the kind of projection that is used for the planisphere. So the world map, it's more or less like an equirectangular projection. What we will do in this case is that, well, at first I will use a pre-existing equirectangular rendering of a 3D scene, and I will consider that this could be a live feed, but in this case it won't be. Nope, not this. I'll just show the image. It been displayed. That's not this. Okay, modified. This one. Okay. So this is a higher resolution of the one that Christian showed earlier, and it's an equirectangular projection. So we will use this, and how we will use the interaction is that we will change the texture coordinates on the 3D model. So I will show it to you in Blender first, so that you get a sense of what is happening, because otherwise it will be a bit obscure. So, you know Blender? Yeah? Okay. These days, who does not know Blender, right? So first I will load the 3D model that I created earlier. And don't hesitate to stop me if you have any question. So workshops, demo, splash, like this one. Okay. I'll rescale it just to make it. Okay. So this is exactly the 3D model. Well, I created the 3D model inside Blender, so obviously it's the same. So that's it. And to make it a bit more obvious that it's the same setup, I will generate a color grid, which, it seems like I used the Blender color grid in Splash. And I will map it onto Blender. So it may not look like it, but Blender is really easier to get into than it was 10 years ago. So if you never tried it, well, it's a very interesting tool. Like Linux?
It's easier than 10 years.
Yeah, indeed. And sorry? Which tool? Oh yeah, 10 years ago. Well, the thing is that 10 years ago, everything was about shortcuts, and now they have icons. And also, they did not meet the industry standard, because Blender existed before there was an industry standard. And so nowadays it's more industry-like, so it's easier to use overall. Well, except for I still use the shortcuts from 20 years ago because I've been using it for too long. So yeah, so what we can see here is more or less the same kind of projection. So so what I did is that if I edit the 3D coordinates, up, I redo it, up. Okay, so this is more like it. So what you can see on this screen, oh, okay. In fact, it's the texture coordinates computed for an equirectangular image. So if I replace this image with, go away, the image that I was trying to load earlier, this one, up, it matches the kind of deformation that is expected for this kind of image. And so if I also change it there, up, frame to go, you see that if I place myself where at the center, so it looks like it's projected correctly. I'm not exactly at the same at the right point at everything, but you see the rails. It's more or less aligned. Well, if I were exactly at the right spot, it would be you would not see the edges of the projection space. So this projection has been computed with the projection center. It's not very obvious, but around this 3D cursor. This is something with Blender. It works a lot with this 3D cursor. And so with this, I decided that the optimal viewpoint will be exactly here at this 3D cursor. So if I put like, let's say I will move it here, and well, okay, I will move it by setting the coordinates myself. Like 0, 0.5, and 0.5. Okay. Still not. Okay. Okay. Yeah, if I put a 3D camera right here, okay, and I just rotate it like this, and I recompute the UV coordinates. Okay, and then if I'm here, you see we can see the edges and everything. But if I place myself where the camera is, it makes a more correct line. It's more precise. It's not exactly what I thought it would look like, but anyway, you'll have to trust me on this. So yeah, and so if I move the projection center, there is something fishy now. Yeah. It worked right before, so why does it not work anymore? Okay. So I must have changed. Oh no, that's okay. Okay. So you see, if I put the projection center here inside the 3D space, and I compute it, it looks like this. So I will go back to this. So we have a wide view inside the immersive space. And if I go back, what will happen is that basically it shrinks my field of view. And this is exactly what we will see. Okay, so this is not exactly what we see. Huh. Okay, well, demo effect, obviously. I told you it would happen. Yeah, I don't know why it's not exactly. Yeah. So I must have hit something along the way. Yeah, it does not work the same. Ah, okay. It must be because I changed the image, and it must be related to that. Yeah. Okay. Okay. Yeah, that's it. That's because of the resolution of the input image. Anyway, so what happens is that whenever I try to compute the 3D coordinates, they are computed around this 3D cursor. So you see the texture, it's really precisely, it goes from the 3D cursor. And so it's deformed around here because of the resolution, kind of resolution of the 3D object, which is not precise enough. There are not enough vertices to store the texture coordinates information correctly so that we don't have this kind of deformation. And so what we'll do is that using live pose, we will control this projection. We will update in real time the projection, the center of projection for an equirectangular rendering. And so I will do it right now. Here, so go back to Splash. So I won't modify Splash because this part is already running, but I will use live pose. So for now, live pose does not have a graphical user interface. So your graphical user interface is your favorite text editor. In my case, it's Vim. So what you have to set is the pose detection backend. So in this case, I use TRT pose with a few other parameters. Then you have to set the cameras that you want to use. So I have a single camera, and as I use video for Linux camera, which is the standard for like webcams on Linux, I just give it the path to this camera, and I also set it to use the PyRealSense API so that I can have access to the depth map, because I want to know how far I will be from the camera. And then I just set a filter, and in this case, it's a filter named eyes follower, so it does exactly what it says, so it follows the eye. And lastly, I create an output, which is an OSC output, so it will send throughout the network, directly to local host, so it won't go through any cable. The OSC messages telling where the eyes of the user is located, and on the port 900. What you get is what you see. What you get is what you see, exactly. What you get is what you read. WYSIWYR. And so, yeah, so I run it. It takes a bit of time because this thing is something that we want to improve, is that it loads all the available model for now. And so, yeah, you see, so this proves that we are able to detect multiple people at the same time. And also this proves that it tries to match from one of you. I don't know which one, but one of you. And so the idea is that well, this is a pocket immersive space. So this is a diorama. The name works in French, but I'm not sure it has exactly the same signification in English. So it's like a mock-up of a space. And so if I put my own eyes in there, it should be able to detect me, but it detects all of you instead. And so I can try to hide you. And yeah, there it is. And then you see, when you don't see, it's very uncomfortable for me. But if I move, the projection, whenever I move, the projection follows me. So you will be able to test it one by one, and and yeah. And so the thing with that is that it reproduces another setup that we did with a scale 1, and I will show it to you because it will make things more obvious, I think.
I just moved the camera so that if you want to pass by and try by yourself, you can do so without hitting the camera so much. So yeah, so this is not the exact same setup, but it's well, it's the same kind of demo. In this case, what we used was a Vive tracker, and it was fixed onto a reflex camera, and so that we know where the camera is located, and whenever the camera is moved, it updates the 3D coordinates exactly like it does here. And what happens is that from the camera point of view, it's like it sees beyond the screen. And yeah, and so you might get the feeling that you would want to look into the walls, which would be a bad idea, obviously. But yeah, and this is the same kind of thing that happens in there. So whenever you move, the perspective is adapted so that you can like navigate into the rendered view, and well, how to say it? It's like the projection surface disappears in exchange for the immersive virtual content. And so once I do that, it should work better with the image that I showed earlier. And so I will just replace it up. So this one. And it was called frame something. Frame to go. Up, here it is. And yeah, so for now it does yeah, whatever, because it detects a lot of you and you are far away. So it's like there is a very thin field of view, and so the texture is very compressed and everything. But whenever it sees well, the closest one, and I really thought it was getting the closest first, but it does not. So this is a bug. But yeah, anyway, that's it. So that's an example. Sorry. That's an example of what can be done using Splash, Live Pose, and if Michał had been with us, there would be sound around all this. This is kind of a simplistic use, because what can be done would be, instead of manipulating the texture coordinates, we could move the camera around in the virtual world. It would work well. Not the same. It would be different, obviously, but you could get some other kind of
well, of effect, and also in the context of having multiple people in the immersive space. So it's not really possible with this. Well, except, well, it is. There could be some interaction depending on what the people do. So, for example, we have some artistic R&D residencies in our lab. So we work with artists to try to use our software to make interesting stuff. And one of them is trying to use LivePose to modify what's projected. So they also use Splash, and to make it so that what's projected is messed with when people are not grouped. So whenever people are not grouped, there are multiple views of the same scene that are superimposed on top of one another, and so the people, they have to come close together to be able to see what is to be seen. I don't know if that was very clear, but so yeah, that's an example of what can be done. Another thing that we did with this is that it's easy from a single camera to get the 2D position onto the floor with a little bit of calibration, and so we were able to track a lot of people and do some interaction like this. Yeah, so
We have about 7 minutes left.
yep.
Let's open discussion.
Yeah, yeah,
Unstructured.
unstructured discussion.
Semi-structured.
So yeah, do you have any questions? Yep.
Yes, have you tried this kind of projection system with stereo projection, for example, with polarized glasses?
Yeah, that's a good question. The thing is that for stereo projection, it's exactly the same as with having objects inside the immersive space. It works for one person at the same time.
Yeah, but this works for another person.
Yeah, well, yeah, this is, yeah. In fact, in this case, it would work. And no, well, in fact, we did not try it, basically. We have some methods which allow for generating stereo projection for domes, which is not obvious because you kind of lose the stereo when you look up. You can't have the stereo projection everywhere, but there are some ways to get it right at the horizon, basically. But we don't have the hardware to do it at the SAT. We don't have the stereo projectors, so we only know how to do it, and we don't have what is needed to do it.
I was wondering if you experienced some phenomenon that I experienced in the past when you show a demo of this system on your screen. It looks like you're really immersed in the environment. You feel a 3D of the environment because you filmed this with a monoscopic camera.
I know which video you are referring to.
In real life, the feeling I got when I saw something like this, it was that the immersion effect was not as striking because you have two eyes. The stereo doesn't work.
Yeah, yeah. So just yeah, I forgot to say the question. So the question was whether the kind of immersion effect that we have in this setup indeed works with real eyes, and as opposed to having something recorded with a monocular camera. And indeed, the first time I saw that was with somebody who did some experience with the Wii sensors at the time. Yeah, that's exactly, yeah. And it works very perfect on the video, but it does not work as well when you try it in real life. And I think this is the same in this setup, but in the dome, it's so big that your stereoscopic view, it does not matter that you have two eyes. The dome is too big. So yeah, it depends on the scale, basically.
So everything is like so far away that you don't have parallax
Yeah, exactly. That's why it works better in bigger space. It's that parallax does not work anymore.
I'm also relaying.
It's a very short follow-up question. But is it? Do you have experiences already working in the dome that we can go and experience with? I mean, can we see that in the dome? This kind of projection system that where you track the participants?
No, we did
Merci. So no, well, in fact, we are in the middle of buying new hardware for our dome because it's quite old now. It was built 10 years ago, and we want to adapt some of our software, especially LivePose, and maybe some other kind of devices like OptiTrack or this kind of tracking devices to especially allow for more interactive experiences, because this dome has not been built 10 years ago for interactive experiences. I don't know exactly why I was not at the SAT when it was built, but it might be because the GPU power needed to render a full dome and at the right resolution at the time was a bit short, I think. So it was not really something that was envisioned. So, yeah.
looking forward.
Yeah, we want to do it. We really want to try this kind of interaction. Yep.
We experimented with speed tracking and speed projection. I imagine you're limited by the refresh rate of projectors as well.
So the question is, did we experience with high speed tracking and projection? I would like to, really, because yeah, obviously, especially in the video of the projection onto mobile objects that we showed, it's really obvious that there is a lot of latency, and yeah, it's latency because of of all the pipeline from the detection to the mapping software, which adds some latency, and the projectors themselves usually they are not, they add some latency too, but yeah, I'd like to. I just don't have the hardware for that.
Yeah, it's costly.
Yes, really.
Maybe not so much the tracking hardware, but
Yep. Well, the other. Okay.
More questions, comments? Well, thank you all for participating to this workshop in presence, in remote presence, and well, we hope you enjoyed the rest of the conference. Well, it has just started, right? So, and if you have any questions for us, please contact us with Discord and through other channels where you can open GitLab issues if you will to file bugs about pose detection, multiple person, etc. We'll be happy to discuss further with you. And with that, thank you again, and thank you.
If you want to try it, it will be more obvious with nobody behind you, but yeah. I can hide people. Or maybe not. It does not move.